So we talked about our different types, or not types of equations, but how chemical equations are what they are. So basically the definition of what a chemical equation is. Now today we're going to discuss the different types of equations. So we're going to talk about main five. We won't really, they all fall into those categories, but there are certain cases that fall into other ones. Now, the one that we are most used to seeing is something like a single replacement or a synthesis problem. So the double replacement, single replacement, and synthesis are all different types of reactions. So if we look at single replacement, we are looking at A plus BC equals B plus AC type of equation, where one element replaces another element in the other compound. So it will always look like element compound equals element compound, or yields element compound. Remember, you can say equals because I'll understand what you're saying, but yields is the correct term for our arrow. That means the reaction. A lot of stuff happens in this area, but single replacement is element compound, element compound. We'll do a foldable later today or tomorrow, and that will be the way that you can distinguish the different types of equations. It is very important. You can use it on your test, just like you can use any of your notes. So double replacement, so using two ionic compounds. This is what we usually see. This is what we've been working with a lot. This is what we did with our experiment with the different multicolored things. So you're taking AB plus CD equals AD plus CB. So you're taking a compound yields a compound. Basically, you're just switching two of the elements together and creating new substances. That's what you're going to do every time. Now, if one of them precipitates, you'll see an arrow. If one of them turns into a gas, you'll see another arrow. Just going back to remembering what we're talking about on the other one. Now, synthesis. Synthesis is pretty simple. You take two objects and you create one product. So two different reactants, or maybe three, or maybe four, and you create one different product. If there is only one product, that is a synthesis. That is pretty simple. That's as simple as it gets. Now, decomposition is the opposite. There's only one reactant. So the reactant decomposes into something new. So that would be like water decomposing into hydrogen and oxygen gases. So your reactant is on the left side, your products are on the right side. So remember, we are trying to figure out, we're basically being detectives to figure out the different types of equations that we're going to do. Oh, by the way, you can always shorten all of your reaction types by just their letters. So SR for single replacement, DR for double replacement, S for synthesis. Now, decomposition is D, and then combustion is C. Combustion must have a hydrocarbon, so it must have some sort of carbon and hydrogen. It must have an oxygen on the reactant side, and it always ends up with energy and carbon dioxide and water. So if it has carbon dioxide, water, and energy on your product side, it is a combustion. If it has an oxygen and a hydrocarbon, just use your context clues and figure out what it is. Now the sixth type is going to be other, so something that does not fit any of these descriptions. Well, you don't have to worry about that. Now, if you find something on your homework like that, then it is probably a mistake on my part, but you'll put an O, that's all you have to do. Now, remember, combustion can be determined by the second area, so make sure you understand that. Now, self-test. So if we look at the first one, we have CH and OH, or H2O, but we only have one product. One product means it is, pause for effect, synthesis. Now, if we look at this, we have one element, one compound element. So remember, if we have the element, compound, or as long as we have one on each side, that's going to be our single replacement. Now, hydrocarbon, oxygen on the reactant side. And on the product side, you have CO2, carbon dioxide, and hydrogen or dihydrogen monoxide or water on the product side. So the combination of the two gives us our combustion. Now we only have one reactant, so it's decomposition. That's simple. NaOH plus HCl equals H2O and HCl. So for one thing, this is an acid combining with a base because we have the aqueous for one thing because they're dissolved in water. We have water as a liquid, so we can say that this is a base and a acid neutralizing into water and salt. But we know this is a double replacement because we have compound on reactant side and compound on the product side. Same thing goes for the second one. So we have our acid and our base, we have our water and our salt, and then we have the combination of compound reactant, compound product. In NaCl, we only have one product, so it's a synthesis. And I believe that is all for today. We'll go over balancing equations, and that is it. Let me know if you have any questions.